Hey everyone, this is Mr. K, and today we're going to practice using logs to solve equations. So the first equation that I have is 3 to the x power equals 70. What I'm going to do is I'm actually going to convert this to log form. So if I write log base 3 of 70, that's going to equal x. If you need to know how to convert from exponential to log form, I have a video on that. Please check that out. Otherwise, it's just, can you type this into the calculator? So I'm going to go to math, go down to the bottom there where I have log base. I'll put in base 3, and then 70 equals that. And so x should be about 3.87. Now, some of you don't have this on your calculator, so there is another way of doing this using logs or natural log. And so I'll use natural log. Doesn't matter which one you use, and we'll show you at the end. So if I do 3 to the x power equals 70, if I natural log both sides, I'll have the natural log of 3 to the x equals the natural log of 70. One of my log rules is that I can then bring this exponent up front. And so I'll have x times the natural log of 3 equals the natural log of 70. And now since I'm multiplying these things to get rid of it, I want to do the opposite. So I'm going to divide both sides by the natural log of 3. And so it's, can you type natural log of 70 divided by the natural log of 3 into your calculator, and you still end up with the same exact answer. And I'll prove to you that it doesn't matter if you use natural log or regular log, because if I do log 70 divided by the log of 3, it still equals the same number. And also note that if I had like the log base 3 of 70, that's equivalent to the log of 70 divided by the log of 3. That's just using the change of base equation, which is also in one of my videos. So that's how you can solve the first one there. The next problem we'll go over here is that sometimes you'll have bases that can be written the same. So like I have 125 here. I know that that can be written as base of 5. And so I'm going to rewrite this as 5 to the third power, and now I can take that to the x plus 2 power. That has to equal 5 to the 2x minus 7. And now if I have a power to a power, I'm going to multiply those, make sure that this is kind of like, consider it wrapped in parentheses. So you have to distribute, but you end up with 5 to the 3x plus 6 power. And that has to equal 5 to the 2x minus 7. And now if the bases are the same, you really can just like drop the base, and those exponents need to be equal to each other. So now I have 3x plus 6 equals 2x minus 7. And now it's just a matter of solving like you normally would. So I'll subtract 2x on both sides. And I'll have x plus 6 equals negative 7. I would then subtract 6 on both sides, and you'll end up with x equals negative 13 as your final answer. You won't always be able to write it as like the same base, but more often than not, that should be something that you can do when you see something like that. If you cannot do that, then one of the best ways to solve that is just by graphing, or you can use logs, but that can get kind of messy. Over here, if I want to solve this equation right here for x, it's kind of trapped in the log, so we're going to have to do some work to get rid of that first. One thing that students like to do is they like to bring this 3 in as an exponent. That's going to make your life much more difficult. It's going to be easier just to start by dividing both sides by 3. So if I do that, I'll have the log base 2 of 4x plus 1, and that's going to equal 4. And now we can take this and we can convert it from log form to exponential form. So it'll be 2 to the 4th power, which is 16. And that's got to equal 4x plus 1. I'll write that down here. This is really 2 to the 4th. 2 to the 4th And so now solve like you normally would. So I'd subtract 1 on both sides. And you get 15 equals 4x. Divide both sides by 4. And you end up with 3.75 equals your x. The last problem that we have here is very similar. The only difference is now we got like an e there. But you still kind of work your way outside in. So I'm going to divide both sides by 6 to get rid of that. You could distribute if you want, but I think it's faster just to divide both sides by 6 right away. I'll end up with 1.5 is going to equal 1 plus e to the x minus 8 power. And then I'll subtract 1 from both sides because we're trying to isolate that x, and you'll end up with 0.5 equals e to the x minus 8 power. And now you need to get rid of the e. And the only way to do that, like the opposite of e to a power, is going to be the natural log. And so if I natural log both sides, a way that I always think of this is that ln kind of looks like the word line. I'm going to put a line through it. And so then I get the natural log of 0.5 is going to equal x minus 8. And then I can just add 8 to both sides. And so it'll be the natural log of 0.5 and then plus 8. If you actually want to type that into the calculator, you can. You should get the natural log of 0.5 and then plus 8. So you should get x to be about 7.31, we'll say. And so thank you very much for watching. Hope this helped, and have a great day, and catch you in the next one.